All right, let's jump right in. We're talking about something pretty mind-bending today. What if AI could design other AIs? This is one of the most exciting ideas in the entire field. Welcome to The Explainer. So, have you ever stopped to wonder, when we talk about these incredibly powerful AIs that are literally changing our world, how are they actually built? I mean, who's the architect behind them? Well, for the longest time, the answer was people. And not just any people. We're talking about brilliant, super expensive teams of experts. PhDs, top engineers, you get the picture. They'd spend months, sometimes even years, tinkering, relying on their intuition and a ton of trial and error to design just one of these complex networks. It's a huge, huge bottleneck. But what if you could just automate all of that? What if you could build an AI to be the architect? An AI that could dream up brand new, powerful designs all by itself and do it way, way faster than any human could even hope to. And that is the core idea behind a field called Neural Architecture Search, or NAS for short. You can think of it like this. It's teaching machines how to build other machines. We're talking about automating the very process of AI design, and believe me, it is an absolute game changer. So to really get why this is such a big deal, let's first dig into the problem it's trying to solve. I like to call it the AI architect problem. You know, when you put them side by side, the difference is just night and day. The old way, it's all manual, it's slow, and it's totally dependent on human intuition, which, let's be honest, has its limits. But the new way, with NAS, it's automated. It can search through a space of possibilities so vast a human couldn't even begin to explore it, finding architectures we might never have thought of. It's a total shift from manual labor to automated discovery. Okay, so how on earth do you even begin to teach an AI to be an architect? This is where a massive breakthrough happened that really kicked off this whole field. So back in 2016, a couple of researchers, Barrett Soff and Kwok Lee, published this incredible paper, and they pointed out something really important. The game in AI had changed. It wasn't about spending all your time handcrafting features from data anymore. The real challenge was designing the architectures themselves, and they had this wild idea about how to automate it. Their big idea was to use something called reinforcement learning. Basically, they built one AI, which they called a controller, and its entire purpose in life was to learn how to design other AIs. And the way it works is this really cool feedback loop. First, the controller AI suggests a design. Think of it like a blueprint. Then a child network gets built based on that blueprint. They test it out, see how well it does, and that score gets sent back to the controller as a reward. It's kind of like training a puppy, right? You give it a treat for doing a good job. The controller gets rewarded for good designs, and it just keeps doing this over and over, thousands of times, getting smarter and smarter with each try. Now, this was not a small experiment. To pull this off, they had to run an absolutely insane setup. We're talking 800 different networks being trained in parallel, each one on its own powerful GPU. The amount of computer power needed was just staggering. So you might be asking, all that effort, all that computing power, was it worth it? Oh yeah, it was totally worth it. The AI-designed network didn't just do well, it set a new record on a major image recognition task. It actually beat the best models that had been painstakingly designed by human experts. This was the moment everyone realized, wow, an AI can actually be a world-class AI architect. So that first breakthrough was amazing, right? But it had a huge catch. It was insanely expensive. You basically needed a supercomputer. So the next big question for the whole field was, how do we make this practical? How can we get these results without needing a warehouse full of GPUs? The focus shifted to making the search itself smarter and faster. Really, it all boiled down to this. Can we do this faster? Can we do it more efficiently? Can we make this amazing technology something that more people can actually use? And the answer was yes, by changing the strategy. Instead of making the AI design everything from the ground up, the newer methods give it a set of really good predefined building blocks. Think of them like high-quality Lego pieces that you already know work well. So now the AI's job wasn't to invent the brick, but to figure out the best way to snap them together. That, plus some smarter search algorithms, made the whole thing way, way faster. And you don't have to take my word for it. The numbers are just jaw-dropping. To hit that same performance benchmark, the original brute force method had to test almost 6,000 different models. The new, smarter approach? It only needed to try about 200. That is a gigantic leap forward in efficiency.
And it's these kinds of efficiency gains that took neural architecture search from being this, niche, super expensive thing only a few labs could do, and turned it into a booming field that's now a fundamental part of automated machine learning. And man, did the field take off. After that first big breakthrough, new ideas started popping up left and right. We got so-called one-shot methods that made things even faster. Then came standardized benchmarks, which was huge because it meant researchers could finally compare their results apples to apples. All of this laid the groundwork for a research explosion. I mean, we're talking over 1,000 new papers on this topic since 2020. It's just incredible.
So where does it go from here? Well, the new frontiers are super exciting. People are working on making the search even more creative, letting the AI discover truly bizarre and novel designs we haven't thought of. They're also making these super fast methods more reliable, so you can just press a button and have it work. And the really big one? Searching for the best architecture and the best way to train it, all at the same time. The holy grail really is what people call AutoDL, fully automated deep learning, where you just give it data, and the whole pipeline, start to finish, is automated.
Which brings us to a final, pretty profound question to think about. As this technology gets better and better, as AI truly learns to design itself, the biggest impact won't just be about having slightly more accurate models. The real question is, what incredible, world-changing problems are we finally going to solve once the human bottleneck of designing AI is gone for good?